Hi there. Well, we're going to be looking at 11.1 as we finish up the semester with this chapter here, chapter 11. And chapter 11 mainly deals with quadratic equations. Now, let's review what is a quadratic equation. Well, I wrote down here as kind of an introduction that a quadratic equation is any equation where you have your highest power being 2. So here we've got our x squared term. Okay, this squared being the highest power makes it a quadratic equation. Whereas if it were a 3, it would be considered a cubic equation, which has a different shape. Now, these quadratic equations, we know when we graph them, and we will be graphing these in the last section of this chapter, we know that when you graph a quadratic equation, you're going to get a parabola, either opening up or for our most purposes, opening down. They can open to the right or to the left, but if they do open to the right or to the left, that happens when the y is squared, not the x. These are not functions because they do not pass the vertical line test. So when it's our x's squared, for our purposes, we'll either be opening up or down. We'll look at that in the last section. And they do form the shape of a parabola because of this even power here, where we know that if we would have had a 4th power, 6th power, the same thing. So we now know what a quadratic equation looks like. And in chapter 6, given a couple of examples, how would we have solved these in chapter 6? Well, we had steps. To begin with, you would look for the greatest common factor. And that was one that people would forget to do, is to look for that greatest common factor and take it out. And in this case, let's go through an example real quick. Here, given this equation, it's set equal to 0, which in chapter 6 is what we expected. We needed to do that in chapter 6. You look for what's in common, and in this case, there's nothing in common with these 3. So that means you would go ahead and you would factor. So we're going to break it apart, and we're going to use our zero product property once we do this. So using the reverse FOIL method, the first times the first gives us this. I'm going to have to change that. Sorry, I meant to have a -5. So then I know that a +5 times a -1 gives you a -5 when you multiply them together. Now the 4 is found using the OI in FOIL, just kind of reviewing here. So you get the inside and the outside. The outside is a -1x, and inside is 5x, gives us a +4x. So we know we've now factored it correctly. We've broken it into parts, which is factoring. So now using our zero product property, I know that in order for this left side to be 0, either the first number has to be 0 or the second number needs to be 0. Each of these parentheses represents a number. So the first number has to be 0. 0 times a number is 0. Or the second number needed to be 0. Anything times 0 is 0. So one of those numbers had to be 0. So we subtract 5, we solve it for x, we add 1. So we had 2 solutions, -5 and 1. And graphically, we'll look at that. What does that mean graphically? But we have a -5 and 1 as solutions for that quadratic equation. And another example here, this was called a difference of 2 squared. And when you have a difference of 2 squares, you can factor. I did set it equal to 0. So if that step wasn't done, you'd have to move it over. And we factor. X times x gives us x squared. 5 times 5 gives us 25. And we have a minus and a plus, so that we have no middle term. -5x and a +5x is 0. So we don't have a middle term. Well, finishing these up using our product property, we have our zero product property. Either that's 0, which means x is positive 5, or that is 0, which meaning x is a negative 5. So we have our two solutions. Now emphasize the fact that we have two solutions. Why two? Well, if you go up to this, the highest power tells you the highest number of solutions you can have. So the most solutions we could have would be 2. We could have 1, or we could have, well, in our cases, now that we have the complex number system, it won't be 0. We could have 0 real solutions, 1 real solution, or 2 real solutions. So the total number of solutions cannot exceed that power right there. It can be less, but it can't exceed that power. So we have our 2 solutions. And you can put those back in and check them. The only problem is that this method that we learned in chapter 6 won't always work. So in other words, what happens if I'm given these 2 equations here and you're told to solve them? Well, you need to ask yourself, if you want to use the same method that we used in the first one up here, what multiplied together gives you a positive 4, and then added together gives you 6? Well, the only numbers that give you 4 are 2 and 2, or 4 and 1. These add up to 4, and that adds up to 5. So we're not able to use a factoring method. However, we do know we have 2 solutions here. And let's look at this other one right here, x squared plus 4. There should be 2 solutions in the complex number system that we now have. And again, factoring this, we learn that when you have 2 terms using chapter 6's method, we had a difference of 2 squares, then yes, it can be factored. But here, what can you square? Add it to 4 and get 0, knowing that whatever you square here, whatever real number you square, comes out to be a positive. Okay, so now that we're going to have some new methods, and we also have a larger numbering system called the complex numbering system. And we'll put those 2 ideas together in order to solve all of our equations. And in this case, it'll be quadratic, where we'll be looking for 2. The highest power will be 2. But some of these methods we'll be looking at, you can use in other with other powers. Some of these can, and we can look at those. But let's concentrate on quadratics and how to solve them. Our first method that we're going to be looking at is called the, let me see where my notes are. There they are, they're buried. Is going to be, we're going to be looking at completing the square, but in order to complete the square, you need another skill, and it's using the principle of square roots. Well, when looking at the principle of square roots, we're going to look at one that we just looked at, which was this one right here. Back in chapter 6, you would set that equal to 0, which is one we just did. You'd factor it. I'm going to go ahead and just kind of quickly write that down here. And our 2 solutions, 5 and a negative 5. Now you could have 1 solution, okay? And so 1 real solution, but we've got these 2 real solutions here, 5 and negative 5. When I say real, they don't have an imaginary part. But with these, we may have some with imaginary numbers as answers. So are there easier ways to solve these? And what happens if you can't factor them? Because here, notice in this method, when you've got these 2 terms, these have to match. Well, what happens if that had been a 7 rather than a 25? What times what gives you 7? What are the same numbers? And so this method is going to be really handy for that, right? For those problems. So we're going to look at those. Let's go ahead and use it with this right here. In this method that we've got, this principle of square roots, in order to solve this, what we're going to do is we're going to get the x squared by itself. That's going to be our first step. So it's a little bit opposite of what we did in chapter 6 in our factoring. And I'm not saying you can't use the factoring. You can if you want to, but in some cases you won't be able to. So here we get the x squared by itself, and we'll be going through numerous examples. And then you take the square root of both sides. So here, in order to get rid of the squared, we take the square root, which we learned you can do. You can do these powers on both, as long as you do it on both sides. Well, we have an x, the square root of x squared is x. The square root of 25 is 5. However, I do know I have the two solutions. So when you're solving these, after this step, you'll always have plus or minus 5. You will always have a plus or a minus 5. And I think that's probably one of the harder things to remember in solving these, is that you'll have a plus or a minus 5. So this is called the principle of square roots, and it's kind of formalized in the box. We'll go through some examples. That if you have x squared equaling k, if you take the square root of both sides, if you take the square root of both sides, you'll end up with a positive square root of k, or you'll also have a negative square root of k. So you'll have the two solutions that we write like this. And you'll notice that when you're doing these, on the bottom of your MyMathLab screen, this button will show up. Okay, that will show up for you. So you can just push it and it'll insert it into your equation. Because we do know that we have both a positive 5 looking over here and a negative 5. We have a positive 5 and a negative 5. So with this method here, when your original has a squared, your original has the squared, make sure you have the plus or minus 5. Okay? Well, let's go through some examples to kind of help you with this idea. This is a part of the completing the square method that we'll be looking at too. All right, let's go ahead, and your first step is to isolate the x squared. So in this case, this first one, we need to get rid of the 3. To do that, I will divide by 3. So isolate that x squared, so we'll divide by 3. This gives us x squared equals 2. Once you have the x squared by itself, you will take the square root of both sides to get that x squared by itself. So or to get the x by itself. So we need to get rid of the squared because we want to know what x equals, not x squared. Now, the square root and the squared cancel out, because remember, the square root is a power of 1/2, and 2 times 1/2 is 1. So you have x to the first. The square root of 2. Well, the square root of 2 cannot be simplified. So it's going to stay, and the reason I'm not going to make it a decimal, you see this word right here, exact? That means no decimal. So if your answer has a radical, you need to leave it as a radical. So my answer is, here's the tough part, plus or minus the square root of 2. Because when I substitute in a positive and square it, I still get a positive 2. If I substitute in a negative and square a negative times a negative is also a positive. So they both work, okay, when you substitute those in. So you'll have the plus or minus the square root of 2. We know that we have the 2, we know that when we have these squared, we'll have the 2 solutions. Alrighty. Let's go ahead and try this next one. Our first step, it's not really too bad, and that is to isolate the x squared. In the last chapter, we isolated the square root, and then we squared both sides. Now we're going to isolate the x squared and take the square root of both sides. So to isolate the squared, we're going to subtract 2. Minus 5x squared equals a minus 2. Now, in order to isolate the x squared, we'll divide by a negative 5. So here, x squared equals a negative over a negative is a positive, so we get 2/5. Fractions are okay. All right, we can have fractions. Now to get rid of the squared, we'll take the square root. So then this x equals plus or minus the square root of 2/5. Now, The square root, plus or minus the square root of 2/5. MyMathLab may take that, and it may not. It's at times. So if it doesn't, it just means that they want you to rationalize the denominator. So if they tell you to rationalize the denominator, we've got some extra steps to do. Always make sure that you see if your fraction itself could reduce. Well, if you look at the 2 and the 5, nothing goes into those evenly. So those cannot reduce. So we're going to go ahead and separate them out. We still have our plus or minus the square root of 2 over the square root of 5. Okay. Now, rationalizing the denominator, we multiply by the square root of 5 over the square root of 5. That creates 2 inside the radical. So looking at the numerator, we still have plus or minus. We multiply those, 2 and 5 and get 10. This right here is the square root of 25. When we multiply them, which is 5. So we have 2 5s. And so we end up rationalizing the denominator. Now again, resist the urge to cancel the 10 and the 5 because the 10 is in a radical and the 5 is not in a radical. So you cannot reduce them. They either have to be outside to reduce, both outside, or both inside to reduce. So there's your answer as a rationalized, with the denominator rationalized. Not too bad. Okay. Again, let's look at another one. Now this is kind of similar to the one that we talked before in the introduction, and that was earlier, if you were asked to solve this one right here, we were told in chapter 6 that there was no real solution. But it didn't mean that there was no solution, there was just no real solution. There's a solution in the complex number system. So we've expanded our number system. And in order to solve that, we're not going to factor. We're going to use this other method, our principle of square roots. Let's go through that here now that we know how. So we're going to isolate the x squared. And then we're going to take the square root. So x equals, well, we've got our plus or minus. The square root of 4 is 2, but that negative square root, we learned in section 10.8, that when you have a negative inside of a radical within the complex number system, it comes out as an I. So the square root of a negative 4 is actually 2i. The square root of 4 is 2. The square root of a negative 1, that's where the I comes from. And so there is your answer. So we now have 2 solutions. It's a complex number. It's actually a pure imaginary number, but it is a complex number in a complex number system. I have 2 of them, a positive 2i and a negative 2i are solutions. If you were to put them in here and square them, you're going to come up with a negative 4. Let's go ahead and let's put one in. Let's put 2i in here and see if it works. 2i squared plus 4. Is it really a solution? Well, we square everything inside the parentheses, so we have 4i squared. Well, we learned in section 10.8 that I squared is a negative 1. 4 times a negative 1 is a negative 4. So it does work in 0. Okay, and it would work for a negative 2i squared. Negative 2i times a negative 2i is a positive 4i squared, which is a negative 4. Okay, all right. So we have a complex number system. We have a new method, so it's opened up some more ability to solve more of these. Let's look at this one right here, similar to the one we just did. Again, we're going to isolate the x squared. So we'll go ahead and we'll subtract 9. So we've got 4x squared equaling a negative 9. Okay. We'll divide by 4. You know, this method is really kind of nice. It's really not that hard. It's not much to it. Guys, try to reduce your fraction. You know, it can't be, but you know, it doesn't hurt to try. So then we take the square root. So we're going to have the square root of x squared, I'm going to move it up here, is x. But what about the square root of 9 on 4? Well, this is the square root of it. We'll put the negative with the 9. Since they don't reduce, you can put them under different radicals. And I would just highly suggest that, you know, if you're going to separate it out like this, make sure, I would just put the negative with the numerator. But it doesn't really matter. But it's a lot easier to do. So here, if you put the square root of 9 is 3. The square root of the negative is an I. So I'm telling you that the square root of a negative 9 is 3i. And then the square root of 4 is 2. But we have to have the plus or minus. You'll always have the plus or minus. In other words, these solutions, these right here, they're conjugates of each other. Remember, a conjugate just changes signs. So you'll always have a conjugate. Okay? All right. But again, there's your solution. Don't forget the plus or minus, and it'll appear down at the bottom in MyMathLab. And then you can just put the 3i over 2. Awesome. All right. I'm sure you guys are doing great. Let's expand it a little bit. We're getting closer and closer to all the skills you'll need to complete the square. In case you have an x to the first term. And I want to also caution you that in order to use this principle of square roots idea, notice there's no x to the first in any of these. There's no x to the first. It's just an x squared. So that you can only use this principles of square roots without the x squared, the x to the first. If you do have the x to the first, that's fine. That's where our completing the square comes in. But for just this simple idea that we were doing, make sure you don't have an x to the first. Okay, let's look at this next one here. Well, in doing this one, you have a squared, and the thing is, it does have an x to the first, but it's inside the squared, so that's okay, because it's inside the squared. We have let f of x equal the quantity x minus 2 squared. Find all values of x for which the function, this is the function, is equal to 7. So in other words, x minus 2, when is the function, this is our function, when is it equal to 7? Well, it's actually been set up quite nicely. We have isolated the squared. The squared is isolated already. We didn't have to move the 7 over. Once the squared is isolated, even though there's something inside the squared, you've still isolated the squared. You take, once you get to this point right here, go ahead and take the square root. Now, when you do that, this squared and this square root cancel each other out. So you're left with x, well, I don't need that, I'm not going to use that parentheses. You're left with just x minus 2. Equaling, now here's the hard part. Because, you know, over here, after we took the square root, we had plus or minus on this right-hand side. So we took the square root, we had plus or minus on that side. And then when we took the square root and we simplified it, we had plus or minus. I could have put a plus or minus in those areas there. Okay, it's not a lot of room. So here, just remember that when I take the square root, this is plus or minus the square root of 7. You've got those plus or minuses there. So, you know, just don't forget those, because MyMathLab will count it wrong. The problem is the x is still not by itself. So I need to get rid of that minus 2. So to do that, I'm going to add 2 to both sides. So the x is now alone. But how do you deal with that right-hand side? I have a positive 2, and I have a plus or minus square root of 7. Well, I highly recommend, you can't combine them together because the 2 doesn't have a square root with it. And this is plus or minus, it's not multiplying. So they have to stay separate. And when you move that number over, put it in the front. So this would be 2, it's a positive 2, plus or minus the square root of 7. So in other words, my answer is 2 plus the square root of 7, 2 minus the square root of 7. But you can write it, it's just a lot easier to write it using that plus or minus symbol. But you do have two solutions, 2 plus the square root of 7, and then 2 minus the square root of 7. Okay, and again, we had our highest power of 2. If we were to multiply that out using the FOIL method, we knew we needed 2 solutions. It just happens to be an irrational solution. It would not have been possible to multiply these out, bring the 7 over and factor, because you can't factor and get a solution like that. There's just no way. Alrighty, so we're getting closer and closer to all the steps we need for completing the square. Okay, let's look at this next one. If you look at the left, okay, normally in chapter 6, we'd say, wow, set that thing equal to 0 and factor it. But in this section, we're not doing that. Notice we've always been moving something over to the right. And in this case, it would be nice if you recognized that this is a perfect square trinomial. So in other words, I can take this, I could take this and make it look like this with a squared. I can take this and make it look like this, so then I can take the square root of both sides. Let's see. Factoring it. Okay. Nothing in common, greatest common factor. Can't forget that. There isn't one. X times x, we're using our FOIL method, gives you x squared. Now, being a perfect square trinomial, it means that I have to have exactly the same in each of these, including the signs. Positive because I wanted a positive 6 when I added them together. 3 times 3 is 9. 3x and 3x is 6x. All right. And so now I can rewrite this and solve it. Okay. And just take the square root of both sides. Take the square root. Once this squared is isolated, excuse me, then you can take the square root, and the squared and the square root cancel out. So we're left with x plus 3 by itself. And we're going to have plus or minus the square root of 2. Because you can take, this can be a square root of 2 and square it, and a negative, you can put a negative square root of 2 and square it. Because of the squared, whether it's positive or negative, you're going to end up with the same answer because of the squared. So that means you can have plus or minus. Okay, now we have the 3. So what we'll do is we're going to subtract 3 from both sides. Well, how do you do that right-hand side? Well, the 3 does not have a square root of 2. And because we're not multiplying it, we're actually subtracting the 3. Put the 3, keep them separate. So we're going to put the 3 in front. And we're going to put a minus 3. And then a plus or minus our square root of 2 down there. Okay, so my solutions are, let me write them out. A minus 3 plus the square root of 2. Square root of 2 is around 1.7. So you'd have like a negative 3 plus, this is irrational, the square root of 2 is, which means it keeps going, it never repeats or stops. You'd have to round it off. So you'd have negative 3 plus approximately 1.71, around in there. And then would be a solution, and a negative 3 subtract about a 1.71 would be the 2 solutions. Rather than write it out like this, it's just a lot faster to write your 2 solutions. Highest power was squared. We better not get 3. Something's wrong. And there they are. They just happen to be irrational solutions because of the square root of 2. It's an irrational solution. Okay, so we have now pretty much most of the steps in order to complete the square. Now, there are times when you'll need to complete the square. And then tomorrow we'll talk about another method other than completing the square. Now, completing the square, you say, well, there's other methods I could use, so why do I need to know how to complete the square? And in solving a quadratic equation, there are other methods that will always work. The thing about this method, however, that you need to know, especially those of you going on to 1400, is that this is used in graphing circles. So if you want to graph a circle, in order to find the center of the circle, you have to complete the square in order to find the center of the circle. So whether or not you use completing the square to solve problems, it's fine, but you do need to understand the method so that when you do want to find the center of a circle, then you'll know how to use this method in a different type of application. So what we're going to do is we're going to go through the steps. And I'm going to use this example as we go through each of the steps. But unfortunately, step 2, we're not going to have until we do the last 3. There won't be a step 2. But we will have step 1, 3, 4, 5, and 6. So let's go ahead. Let's learn how to complete the square. Now, we talked about this equation earlier in the introduction. And you're asked to solve this. And it says by completing the square, but what happens if, could you factor it? You know, rather than completing the square, could you factor this? You'd have to ask yourself what 2 numbers multiplied together give you 4, but added together give you 6. And that's not possible. So we could not use the methods from chapter 6. So we're going to use this completing the square, and then we'll look at another method tomorrow. To complete the square, the first thing you do, step 1, is to isolate the terms with variables. So I have 2 terms with a variable. Our first term has a variable, and the second term has a variable. We need to isolate them, which means the 4 has to go to the other side. So our first step is to move the 4 over. Get rid of any numbers. X squared plus 6x. I'm going to leave a space. Equals a -4. And you'll see that why here in a minute. Okay, to complete the square, what we're going to do is we're going to create something that looks just like this right here. That's our goal, is to get something that looks like this so that we can factor it, write it like this, and take the square root. It has to be a perfect square trinomial. We're going to create a perfect square trinomial so we can do this and then take the square root. How do you do that? Not really too bad. Now, this step 2, let's talk about it real quick here. Divide both sides by the coefficient in front of the x squared if it is anything other than a 1. Ours is a 1. Okay? If it's not a 1, we have this extra step. But for the first 3, for the next 3 is always going to be a 1. So we're not going to have that step 2. Step 3. Now, take half of the coefficient in front of the x. Square it and then add it to both sides. You go, wow, what does that mean? Well, take half means to divide by 2. So you're going to divide 6 by 2. And you're going to get 3. Then you're going to square the 3. Oops. I wrote 3. Square the 3, and you get 9. And you're going to add this 9 to this side, but to keep it balanced, you have to add it to that side. So what I say is you take the middle term, because the middle term, if we wrote it correctly, is the x to the first term. You take that, divide that by 2, get 3, you square it, you get 9, and that's what you add to both sides. So what happens is that we have x squared plus 9, x squared plus 6x plus 9 equaling 5. So it looks exactly like the one we just did above, just that last example. We can factor this, plus 3 and plus 3. This spot will always come from this number right here. This number that you're squaring will always go here. And that's going to help us out when we do fractions. So 3 and 3 is 9, 3x and 3x is 6x. Okay. And now we take the square root of both sides. Don't forget your plus or minus the square root of 5, which cannot be simplified. So then we subtract 3 minus 3 plus or minus the square root of 5. And there's our solution to this equation, which could not have happened. You could not have known that it's an irrational solution, but we couldn't have done that by factoring. So we have this completing the square. So again, to find out what you're going to add to both sides, take your middle term, the 6, or the number in front of your x to the first. Take the 6, always divide by 2, always. Once you get your answer, after you divide it by 2, you square it. And what you get is what you add to both sides. And then that way it allows you to factor. And this number 3 will always be the number that you squared to get this one. Okay? All right. Well, we're going to go through those steps 3 more times. You can always stop and try one and see if you get it right. Okay. Step 1 is to get rid of this minus 7. You only want the x squared and the x on the left-hand side. So there's our step 1. And always leave space because I know I'll be adding a number here. Okay, and you always add that number. This term right here, you'll always be adding it. Always. It'll always be plus here. So now we take our term that has the first power, we take the negative 8. Okay, it's always the number in front of the x to the first. We're going to take a negative 8 and we're going to divide that by 2. When I always divide by 2, I get a negative 4. Then you're going to square it. And that gives you a positive 16. So you see what, because we're squaring it, it'll always be a positive we'll be adding to both sides. Plus 16. So we divided by 2. We squared it. It'll always be positive because we're squaring. And that's what you add to both sides. So we end up with x squared minus 8x plus 16 equaling, let's see, 23. 7 plus 16 is 23. Okay, this side will always be a perfect square trinomial every time. So when we factor it, x times x, we squared the 4, so we'll have minus 4 minus 4. We squared a minus 4. I mean, you can check it. Go ahead and check this. You know, did I do this right? Minus 4 times a minus 4 is a positive 16. Negative 4x and a negative 4x is a negative 8x. So it worked out perfect. So now we have 2 of those. Pretty cool. And we'll take the square root. So that leaves us with x minus 4 plus or minus the square root of 23. Okay. And then we'll add 4. So we have x by itself plus or minus, so I'm going to put the 4 in front, square root of 23. 4 plus the square root of 23, 4 minus the square root of 23. Those are our solutions. And again, just use a plus or minus because it's a lot easier to type it in MyMathLab. All righty. Let's go on to the next one. We're going to complete the square. Our first step. The first step is to move the 3 over because we want the x squared and the 5x by itself. So I added 3. Okay, so now the problem is, okay, well, it's not really a problem. We have to deal with a fraction, but that's okay. We have our term, our 5 here, or our coefficient in front of our x to the first. We take that and we divide it by 2. Well, rats, it doesn't go in there evenly. You know, like the last one. We took our coefficient to our linear term, to our term to the first, and we ended up with a whole number. That was nice, -4. But we don't end up with a whole number. So we're going to leave it as a fraction, and we're going to square it. And we're going to get 25/4. Okay, when I square it. So I divided by 2. I couldn't simplify it, so I'm just going to leave it. Then I'm going to square it. So I divided by 2. Then you square it, and you get 25/4. Okay. Now this side right here, we're just going to write x squared. You guys have calculators, so taking 3 plus 25/4 shouldn't be that big of a deal. If you don't, getting a common denominator so that you can add them, this is 4. To go from 1 to 4, you multiply by 4. 3 times 4 is 12. So 12/4 is the same as 3. Okay. Multiply the denominator, multiply by 4, multiply by 4. So it looks like we're going to come up with 37/4. Yep, 37/4. Okay, let's factor the left-hand side. Well, it looks harder than it actually is, because remember, x times x gives you x squared. What times what gives you this? We did it right here. 5/2 times 5/2 gives you this. Okay. Just like in the last one I told you, after you divided by 2, that is -4 is what we put here, okay, in those spots. So it's whatever you're squaring is what's going to go in those spots. Pretty nice. So what did you square to get 25/4? Well, this times this gives you this, and I want pluses. Do you get the middle term? Well, this is 2.5x, and 2.5x is 5x. So you get that. Okay. So let's go ahead and take the square root of both sides. So we end up with x plus 5/2 equals plus or minus the square root of 37. This cannot be reduced with the square root of 4, which is plus or minus the square root of 37 over 2. So I did simplify that right-hand side. Now I will subtract 5/2. So x then is being equal to a minus 5/2 plus or minus the square root of 37 over 2. You're done. Maybe one of the harder parts was realizing that the square root of 4 could reduce, but the square root of 7 stays in. And you still have the plus or minus. And there's your answer. Those are your 2 solutions. Now you have to work with some fractions, but it's really not too bad. All right, let's try one more, and then we'll look at how to incorporate step 2 that we haven't done yet. So let's get these by themselves. Yeah. So we've got x squared plus 6x. I always like to leave a little bit of a space because I know I'll be adding something to both sides. I'm going to bring the 5 over. I'm going to add 5. All righty. Now, we're going to take, this is the step 3 actually. We'll take and we'll divide this by 2. And when we do that, we get 3. And then we'll square it. And that gives you 9. Okay, so we'll have plus 9. Remember, we're always adding. We're always adding. Whatever we get here is always added to both sides. We won't be subtracting from both sides. So we've already done this one right here. This is x plus 3 squared. Okay, x plus 3, we've done that a couple times now. Equaling 14. Okay. Wow. Take the square root. So we have x plus 3 equals plus or minus the square root of 14. See if you can reduce the square root of 14. You know, we did have to do some reducing up here, and that was the square root of 4 underneath. But this one cannot be reduced. So then you just subtract 3. X equals a minus 3 plus or minus the square root of 14. So your solution was irrational. You've got 2 irrationals. Irrational. A negative 3 plus the square root of 14, the 3 point something would be the square root of 14, and then a negative 3 minus the square root of 14. Square root of 14 being irrational. It will just keep going. It doesn't repeat or stop. So you'd have to round it off if you wanted a decimal. Otherwise, this is called the exact answer. And if they ask for that, make sure you don't put a decimal. Okay? All right, let's look at our step 2 and then we'll be done. Now, the step 2 deals with a number. If you'll notice all along this page here, we have a number in front of our radical. And how do we incorporate that? Well, first off, go ahead and you can move the 2 over here. We'll do our step 1. I'm gonna, a little rough. Plus 7x equals 2. Okay, what you're going to have to do now is you're going to have to divide everything by 3. So you need to get a 1 in front of the x squared. So we're going to divide everything by 3. So you divide by 3, divide by 3, divide by 3. So x squared plus 7/3 x equals 2/3. You know, and I know some of you think working with fractions is a nightmare, but with the calculator, I'm hoping that it won't be too bad. Okay, so what do we add to both sides? To determine what we're going to add, we need to take 7/3 and divide it by 2. But you're saying, wow, you know, that's a fraction. Because this is a fraction, can we think of it as rather than dividing by 2, multiply by 1/2? Okay. Dividing by 2 is the same as multiplying by 1/2. It's that copy dot flip. So I'll just go ahead and go through a little bit of your math here. Taking, oh yeah, you can see that. Taking 7/3 and dividing by 2, we always took this coefficient in front of the x to the first, and we always divided by 2. This is the same thing going back to our chapter 7 as 7/3. It's a copy dot flip, because this is 7/3 divided by 2. And you can do a copy dot flip. So it, you know, that helps in that when you simplify this, you get 7/6. And that's what you're going to be squaring. So when you have that fraction, rather than divide by 2, realize that dividing by 2 is the same thing as multiplying by 1/2. They mean the same thing. And so here when we square it, we're going to get 49 over 36. That's what we'll be adding to both sides. So we're going to take plus 49 over 36 plus 49 over 36. Okay. And let's see, this right here stays. I think I've got enough room over here. Equals, you're gonna have to take 2/3 and add 49 over 36. This, making this a 36 down here, you'd multiply by 12. So multiply that by 12. So times, oops, sorry. So you multiply it by 12, multiply it by 12. And that gives you 24. And comes out to be 60, 73. Make sure I double check on my math. Yeah, 73. So again, you have calculators, take 2/3 plus 49, 36, and make sure you change it back into a fraction. So on the right-hand side, we have 73 over 36. Okay, let's factor. Well, remember, you've got x times x. What goes here is what you squared to get that. Because you take 7/6 times 7/6 to get that. Okay, and everything is pluses because you want a positive 7/3. And if you take 7/6x plus 7/6x on your calculator, you'll get 7/3. And we end up with x plus 7/6 squared. And then we'll take the square root of both sides, which leaves us with x plus 7/6. The squared and the square root cancel each other out. Plus or minus. This won't reduce, the 73 and the 36. So I'll keep them separate. And the square root of 36 is 6. So I did reduce the square root of 36. And you have a plus or minus. And now you subtract. Subtract 7/6. So minus 7/6, that's this, plus or minus, wow. The numbers aren't pretty, but my math lab never really tries to have pretty numbers. Okay, the steps are pretty much the same, except for this one did have step 2 where you had to divide. And what happens, it created a fraction. And dealing with fractions aren't too bad. Just instead of dividing that middle term by 2, you multiply by 1/2, which means the same thing. So that gives you 7/6, which is what you square to find out what you're going to add to both sides. Okay, and then this stays. I added these together. Then you factor. How do you know the 7/6? It'll always be what you squared. Okay, here. And then just take the square root. Don't forget your plus or minus. Reducing each of these, if they can be. If not, leave them. And then brought the 7/6 over. Okay, wow. Let's try another one, you guys. All right, the linear term and the x squared term are over by themselves. So it's going to have to divide by 4. That gives us x squared plus 2x. Well, that's nice. I don't have my 7/3 like I did above. I'm going to leave a space. All right. negative 3/4. So we're going to take our middle term, instead of multiplying by 1/2, which you could do, 2 times 1/2, I'll go ahead and divide by 2. So 2 divided by 2 is 1. Then you square it, you get 1. So you're going to add 1 to both sides, which means we have 2x, x squared plus 2x plus 1 equaling a negative 3/4 plus 1 is 1/4. All right, and then we will factor this. X times x, 1 times 1 is what you squared that goes in those spots, plus. And it doesn't hurt to check it. It'll work. There's a little delay there, but that's okay. So now we'll just rewrite this. Okay. That's a little sloppy over here, but it's 1. Okay. And now we take the square root because we got our squared by itself. So we have x plus 1 equals, well, this is plus or minus. We know it's going to have a plus or minus at this point. And this doesn't reduce, the 1 and the 4 don't, but the square root of 1 is 1, and the square root of 4 is 2. Let me write that better. So again, I just reduced the square root. So this is the square root of 1 over the square root of 4. The square root of 1 is 1. The square root of 4 is 2. There's no radical here. Wow, this is awesome. So then you subtract 1. X equals, we have a negative 1 plus or minus 1/2. You can simplify this further. This over here, up here, and all the other ones we've had this radical, so we could not add or subtract with a number without that same radical. But in this one, we don't have the radical. So our answer is a negative 1 plus 1/2 or a negative 1 minus 1/2. We can add these numbers together. So this gives us a negative 1/2. Negative 1 plus 1/2 is a negative 1/2, or a negative 1 minus 1/2 is a negative 3/2. So this is your answer. So if for some reason, when you do your plus or minus, if all the radicals drop out, you'll be able to simplify it further because you don't have a radical there. You don't have to stop. You can keep going. So keep that in mind. All right. Last one. See what we can do here. And none of these had an I. We never had a negative in the radical. I'm not saying it can't happen, but in these cases, it's not. Okay, so here, let's move the 3 over. Divide everything by 2. This is our step 2. Divide by 2, divide by 2, divide by 2. X squared minus 5/2 x equals 3/2. So it looks like we've got some fractions to deal with, but it won't be too bad. So taking this term, this coefficient that has with the coefficient to the x to the first term, okay, rather than divide by 2, I'm going to multiply by 1/2. So I'm going to have a negative 5/2, and then I'll square it. So a negative 5/4 is going to be a positive 25/16. So instead of dividing by 2, I multiplied by 1/2, and that gave me this. Now remember, this has significance when we're factoring. That's going to go in that last spot, -5/4, -5/4. And then when I square it, I always get a positive, so I'll be adding a positive 25/16. So I have x squared minus 5/2 x plus 25/16 equals, to get this to a 16th, multiply by 8. So 24/16 plus 25/16 is 49/16 on the right-hand side. Okay, let's factor that left. And again, I know what goes in the last spot. It's the number I squared, which was a -5/4. The last times the last is a positive 25/16. -5/4 and a -5/4 is a -5/2. So I have x minus 5/4 squared. Okay, take the square root. This leaves you with x minus 5/4 plus or minus. All right, square root of 49/16. Well, the fraction itself can't reduce, but the square root of 49 is 7. The square root of 16 is 4. So our radical disappeared. That means we're kind of back up to here where we're going to be able to go a little bit further. We'll be able to combine that last term with the first term. So we'll add 5/4. I'm going to have to go over here to the, well, I can write it here. I'll have 5/4 I'm putting in front. I always put that in front. Whatever you bring over, put it in front of your plus or minus. Common denominator, that's pretty nice. So we take 5/4 plus 7/4 is 12/4. 5/4 minus 7/4 is a minus 2/4. So in other words, you add the numerators because the denominators are the same, and then you subtract the numerators because the denominators are the same. 12/4 is 3. -2/4 is a -1/2. And there's your solution. Could you have gotten this by factoring? Okay, because these aren't irrational. Yes, you could have. You didn't have to go through completing the square in order to find these. Whenever you end up with a fraction, it means that you could have factored those. And we may come back to these exact examples to see what this means, but you could have factored those, these last two, and come up with the answer. But I wanted you to keep practicing completing the square, okay? Our other method. Well, it looks like that's it. And again, if you have questions, please let me know as we finish up. Hopefully you finish strong. And again, if you have any questions, please let me know. Have a great day. Talk to you later. Bye-bye.